Well, I'm going to go ahead and get started here. I know there's some others coming in, and I'll go first with some introductions. My name's Brian Beathard. I'm with RevHD, sort of a new company. We've been around now 7 years, and that's still a baby in this industry. But I often tell people we're a new company with an old soul. The guys who started the company all came from the other seal manufacturers, the ones you're aware of. Most of them came from Stemco. There were some key people from National that came on board early on. Here recently, about 2 years ago, we hired the lead engineer from SKF. So the products we make have collectively, between the engineers that we've hired from the big three, 75 years of seal experience behind them. But this isn't meant to be a commercial for RevHD. Obviously, I'll tell you a few things about us as we go along, but this will be 95% class, training class for technicians. It's a class that we can do at any of your shops, but we also offer this online. If you go to RevHD.com or tell your techs to, then they can go through this class online. But we also offer it live, and it's a pretty good class. Usually the best tech in the shop, the one who starts off saying he can't learn anything new, will come out of it saying, you know, I picked up some new nuggets of information, whether that be new products that have come out, new changes with CVSA, or just rehashing some old stuff that maybe he forgot. And hopefully this class is going to do the same for you guys. There is a certificate that you can get after this class is over. If you go to that same website that I just mentioned, there's a quiz. Take the quiz, make a 85 or better, and you'll get a nice certificate. And one of the things RevHD does is if you do use our seals and you have this certificate, our warranty includes the brakes, which is kind of nice. I'm not aware of any seal manufacturer that'll pay for your brakes if the seal leaks. We do if you go through this course, the one you're taking today, or the online version. So these are the items we'll be discussing. The wheel end, as it's generally called in the manufacturing world, doesn't include the brakes or the tires. It's generally the hub and all the components around it. So we'll be talking about the spindle and all the aspects of the spindle, the shoulder, the journal, the threads. We'll obviously talk about the seal, different types of seals, what causes them to fail, what you can do or your technicians can do to help prevent premature seal failures. We'll talk about the bearings, different things to look for when you inspect them, and different types of bearing adjustments. To me, the most important part of this class is the latter part of the class where we'll cover all the different bearing adjustments, preset hubs, as well as the old manually adjusted hubs, double nuts, as well as the new single nuts. In addition to the nuts, we'll talk about the hubcap and the gasket. And then again, with the nuts, there's different ones out there, and we're going to cover all of them, the double nuts as well as the new single nuts. And with the hubs, we're going to cover the manually adjusted hub as well as the new preset hubs that have kind of taken over the world. So why is all this important? I've got a quick video here that's meant to scare you a little bit because this is important stuff. You know, training is good, and in all aspects of what you do, training is important. But it's a little different if you mess up on, say, the HVAC system or something that's a comfort creature for the driver versus messing up on the wheel end. And this video, I think, points to that. Online and find many, many more videos. It's scary stuff. Wheel offs are a scary thing. Some of you guys may have been in the previous class where they were talking about some of the liability issues that drivers and companies face. A lot of that is driver neglect. Some of it's brakes. I think third on the list is something having to do with a wheel off or a fire. And oftentimes that has to do with either the installation of the seal or the bearing adjustment. This is a picture, unfortunately, the newlywed couple both perished when a set of dualies came through the car. It's not something you want on your conscience. It's not something you want in your history, and that's why this class is hopefully soberingly important. So in a nutshell, just always remember to be safe, be careful, be thorough, be smart. And it's taking training classes like this that can help you be smarter and be better and be more careful. We have a saying at RevHD, do it once and do it right. This is just another way of saying anything worth doing is worth doing it right the first time. So we're going to talk about all of those components, and I'll try to talk about them in order of how you would pull them down and inspect them. We'll start off by talking about some of the things that can make a seal leak. Truth be known, there's 100 things that can make a seal leak. And a little bit about my background. I've been around the wheel end for 30 years. I was with Stemco before coming to RevHD. Was with Stemco for 11 years. Prior to that, I was with a Goodyear Tire and Rubber Company. I've been with RevHD for about 7 years. I don't think I've seen it all, because you never see it all, but I've seen seals that leaked because a Barbie doll arm was stuck between the seal and the hub bore. I told that customer that was reason number 67. The seal is the weakest link in the chain, and it's designed that way on purpose. The engineers want the seal to fail before the bearings fail, before the hub fails. So it is the weakest link in the chain on purpose. And out of the 100 things that can make a seal fail, there's 5 that kind of float to the top. That if you call Stemco or RevHD or National or SKF and talk to the warranty department, they'll tell you these 5 really resonate as making probably 90% of the seal failures that they get back into their warranty department. And I'm going to give you a remedy for all 5 of these. Not necessarily in this order, but probably pretty close. Bad installation or a cocked seal. Those are kind of in the same category. Bad installation can be someone not using the right tool, hitting it too hard, or getting the seal a little crooked when they drive it in. They can also put the seal in perfectly, but when they go to dock the hub, wrestle with it or hit the spindle, and everything they were doing before that they did textbook now goes out the window, because you sometimes see these guys try to manually get that hub up onto the shoulder as opposed to letting the bearing adjustment kind of do that for you. Another big factor in seal failure, and really wheel end failure across the board, is the bearing adjustment. That will be probably half of this class, and to me, again, the most important part of the class. Too loose or too tight. And it's hard now. There's a lot of different systems out there. And the makers of each system have different specs and different preset hubs with different spacers, and I feel for technicians right now. The old days where you could have one bearing adjustment in your back pocket and that worked on a drive, steer, trailer, car hauler, school bus, cement mixer, those are long gone. Now the bearing adjustment you did on a 2010 Freightliner steer may be completely different than the bearing adjustment you're doing on a 2011 Freightliner steer. Bad shoulder, bad hub bore. I think that goes without saying. Bad equipment, that can cause premature seal failure. Contamination, not cleaning properly in the beginning, or contamination getting into the wheel end after it leaves the shop, particularly for off-road vehicles. And then this one slips by a lot of people, the hubcap vent hole or the drive vent. Both of those need to remain unclogged. And it's a simple thing, but if you've done everything perfect and that hubcap plug has that hole in the center of it, if that's not breathing properly, that pressure building up in the hub has to go somewhere, and oftentimes it'll blow out the seal. So those are the top 5, and we're going to give you remedies for all 5 of those today. And again, the online class that this is modeled after does the same thing if you want to have your technicians go through it when you get back to your shops. True or false? A moist or a damp seal is okay. Not all at once. Hearing some falses. Anybody want to say true? Got a true over here? Okay. It's a little bit of a trick question. The true answer is true. It is okay. And the safety regulations handbook that the DOT uses says it. But a lot of times it kind of depends on the DOT inspector you get. And again, I sat through a little bit of the last class where they were talking about accidents and how dramatically an accident report can be written up based on the police officer and his tenure and his knowledge of tractor trailers and how they work and how they operate. Kind of the same thing here. But if you ask a seal engineer from Stemco, National, SKF, they'll tell you they actually prefer to see a seal be moist. Kind of like shock absorbers or shocks, where they want to see the moisture there as opposed to being bone dry. There's some problems that can come if you have seals that are bone dry. So there should be actually a little moisture there. Either way, you're okay. It's when you have dripping or lube that's about to begin dripping onto the brakes that you have an issue. So diagnosis. Let's talk a little bit about wheel end issues. Maybe you have a problem child. In other words, a wheel end that's just constantly giving you heartaches. There are some things you can look for before you tear that wheel end down that might give you some clues as to what's going on. You know, what does the hubcap look like? Is the plug, the hole in the center of the plug, is it clogged? What does the drive vent look like? Same issue there. Is it clogged? Is there oil on the brakes? And what about the in play? One of the things you're going to hear me harp on, like a Baptist minister today, is that you really should dial indicate your wheel ends every time you put them back together. You don't normally dial indicate them when they come in, but you might think about doing it if it is a problem child, or it's a seal that you just installed, or something really has you scratching your head. Because once you tear that wheel end down, where does that information go? It's gone, right? It's gone forever. So you might consider, if it's a problem child, it's an anomaly, it's one where the customer's really upset, you're really trying to figure this thing out. Do a dial indicator, take a dial indicator and take a measurement before you tear the wheel end down. It'll give you some clues possibly as to what happened. And then as you tear everything down, inspect it. And that's where we'll start with the hubcap and kind of go all the way through. What are some things to look for on the hubcap? Mostly common sense. Again, we've talked about the plug already. You do want to keep them clear, but here's a caveat. Make sure you use something the diameter of the hole or smaller to clear them out. I tell guys a lot of times use a paper clip. But anything the size of the hole is fine. Don't use a pocket knife or a screwdriver. You don't want to make that hole any larger because then it can start letting water in, dirt and debris and that sort of thing. Check the window, if there's cracks in the window, if there's heat, if it's grayed out or it's bulging. Again, as I said, throughout this, I'll pepper in a little bit of commercial for RevHD. RevHD is coming out with a hubcap in probably 2 months. It's got some unique features, one of which are these cross members that cross the lens. It's the only hubcap that has a warranty against lens cracking, and it's a lifetime warranty. In fact, we're not even going to sell window kits. If you have one of these hubcaps and the window breaks, you get a free hubcap, and that includes off-road. Just so you know, everything we make at RevHD is kind of made under the auspices of off-road. We continuously think of off-road when we engineer our seals, the nuts, the hubcaps, with the idea being if we can work good in that environment, going over the interstate should be a piece of cake. It'll also come with all the hardware, including the bolts, the gasket. One of the bolts is going to be a unique bolt. We call it the heat check bolt, and it'll come for free in every box. The technician puts it in just like he does the other bolts. But when that vehicle, that tractor or trailer leaves your shop, this one's going to continuously monitor the temperature of the hub. And if the hub temperature reaches 250 degrees, the kind of temperature that can cause some of the things you saw in that video, that center piece is going to pop out, just like a turkey baster. But in this case, it's telling you there's something wrong going on inside that wheel end. It may not be obvious from the outside, but internally something's going wrong. Could be a lack of lube, could be water in the lube, could be metal shavings getting into the tumblers of the bearings, or the bearings just simply aged into the point that they're starting to lock up. Could be dragging brakes, could be a number of things, but at 250 degrees, you're entering that realm where it's not a maybe. It's not a hot day in Phoenix that caused it to pop. It's something going on that you want to catch before it gets any hotter. At 350 degrees is when you start to enter the realm of a wheel off or a fire. We're hoping this plug actually saves lives. Examine the locking nuts as you take them down. Are they double nuts? Are they single nuts? What are some of the things you want to look for? Obviously, you want to look for chisel marks. If you've got nuts that have those chisel marks, I would not go back with them. You also want to check the threads. Are they all there? Are some of them missing? Are they boogered up? Really, when it comes to these nuts that you're using to lock in the wheel in, anything that gives you cause to pause, I would err on the side of caution and go ahead and replace them. And with the double nuts, they do recommend if you replace one of the nuts in the system to go ahead and replace them all. They're made out of soft metal and they tend to marry with each other. There are also single nuts out there, and there's different types. There's the Axi lock, which has the tabs. The tabs are kind of the Achilles heel of that nut. You want to make sure those tabs are engaging, that they're not bent out of place, they're not missing. Axi lock actually wants you to use a new or newer socket when you put these on, not one that's, as we say in the South, wallered out. A wallered out socket, or one that's got wear in it, can cause those tabs to bend or break out of place as you're doing these torques at 200, 250, 300 foot-pounds. There's also single nuts out there that have a C-clip or a retainer, and you've probably seen a lot of those out there. There's different makers and different manufacturers of them. You've got Stemco, you've got Temper Corporation, who is here today. And they all work with a C-clip, and that's the Achilles heel in that you have to make sure that clip is engaged correctly. And there, what you want to watch out for is that all three tabs are locked in place. None of them are on the outside of the nut. They're all inside the nut. And we'll talk a little bit more about that and how to check for that a little later on. What can we look for on the seals? So again, this seal is leaking, and maybe you only put it in a few weeks ago. Is the spring coming out? Is it missing? Are there any dents in the face of the seal, indicating that maybe it hit the spindle as it was going on? I actually think most seal issues in terms of damage before it leaves the shop occur at the point of docking the hub. I've watched a lot of guys install seals over my years, and most of them are careful. They've got the right tool. They're on a flat surface. They're listening for that change of pitch, and they're checking the seal afterwards to make sure everything is good. That same person, though, tends to grab that hub and, like they're in WrestleMania or something, and try to force that thing onto the hub, and they'll hit the spindle, or they'll hit the shoulder, or they'll wrestle with it to the point that they cock the seal. Or sometimes, and I know you've all seen this, and we're all probably guilty of it, they'll let go of the hub to go back and grab that outer bearing. And what's the hub doing now? Yeah. Which can damage the seal and or cock the seal. Check the ribs on the inside of the seal. Sometimes when you're, docking the hub is where a lot of this happens. They'll drag the seal across the spindle threads. And that's going to tear that rubber, and that's going to give you a leak path. So look for indications that might tell you that's going on. Here's a tip that I kind of threw in here. It is a good thing to try to pry your seals out of the hub as opposed to punching them out. And again, I know a lot of shops are going to do what they're going to do, but if you punch the seal out by using the bearings, I wouldn't go back with that bearing. You probably damaged it. You probably lessened its integrity. If not when you punched it, then when it fell out and hit the floor. There are seal pullers that you can get. They work really nice. Here's another tip. Usually when you're doing this, you've got that drum laying close by. Flip it over, and now you can put the hub down in the drum and use it as leverage. And now even if you don't have a seal puller, a typical crowbar will allow you to get that seal out, and that'll save the bearings. So speaking of bearings, what are some things we can look for there? Pitting and spawing is a big one. Check for that. Make sure all the rollers are smooth, none of them are pitted, and that they're all rolling smoothly. Check for dents, again, where somebody might have used the bearing as a punch or a drift. I find a lot of times these bearings come in pretty flimsy boxes. I've never understood why they do that, and probably everyone in the room has either had this happen to them or seen it happen where you grab the bearing off the shelf and it just falls right out of the box and hits the ground. If that happens, any dent, small or large, you need to throw that bearing away. Watermarks. A lot of times you see this on equipment that sits idle for long periods of time, maybe school buses during the summer or construction equipment during the winter. And then, of course, heat damage. Heat scorching, as it's technically called. Some guys call it bluing. And a lot of times it is a bluish color, but it can be black, brown, purple, yellow. Any discoloration that you can't scrub out, that's heat damage, that's heat scorching. And again, I would not go back with that bearing. Kind of like with the nuts, anything that gives you cause to pause with regards to the bearings, I would replace them. And anytime you replace a bearing, you should also replace what? Absolutely. Cup and cone. I prefer to see guys buy them in match sets. What to look for on the hub? Check the ABS sensor ring. Check especially with concerning the seal, check the hub bore itself. A lot of guys will look at the spindle shoulder, and that's great for the ID of the seal, and they might not inspect or as closely examine the hub bore. Well, that's where the OD of the seal rides, and both of those surfaces need to be clean, fresh, without, as best as possible, any pitting, spawing, scratches, that sort of thing. A great tip. This will make any seal last 10% longer. Take some emery cloth. This is after you've cleaned everything. And spend about a minute on both the hub bore and the spindle shoulder. It prepares that surface for the seal, and it allows any seal, cheap or expensive or in between, to have a greater life out there on the road. So it's a great tip. I encourage you to add that to the things you're doing when you put a wheel end back together. And then what do we look for on the spindle? Obviously the shoulder, pitting, spawing, chisel marks. What might cause a chisel mark on a spindle shoulder? Anybody ever removed a two-piece seal? Where you've got the speedy sleeve or the wear sleeve, and sometimes guys will use a punch or a drift. That can cause a chisel mark or a scratch, a deep scratch embedded into the spindle shoulder. That's going to be a leak path in many cases. I'm going to give you some tips later that'll help remedy it, but it'll be a problem for you going down the road. And then a lot of guys neglect the threads in the bearing journal or the spindle journal. Check underneath the spindle for wear. You're trying to feel a flat spot. This is another great tip, guys. In fact, anytime someone calls me and they say, Brian, I'm needing help here. I've got a problem child. I've got one I've put every seal in it. I've sent it to the dealer maybe. I've had all my techs look at it, and this one wheel end is just coming back all the time with a leaky seal. At that point, I'm assuming you've done the low-hanging fruit. And what I'll tell that guy over the phone is reach underneath the spindle, particularly back at the base where the shoulder is, and see if you can feel a flat spot. If you can feel it, it's already beyond the point of fixing. You'll need to get an axle surgeon out or get a new spindle. But if you can't feel it, you might go ahead and take a micrometer or a caliper, measure between 9 o'clock and 3 o'clock, and then take another measurement between 12 o'clock and 6 o'clock. If the difference between those two measurements is greater than 6 thousandths, then that's your culprit. It'll be hard for any seal, two-piece seal with silicone and Permatex, to hold very long on a spindle that's got that much wear. That's where the weight of the bearings is riding up against the spindle, and that's where you'll get the wear the quickest. And because it's underneath, it gets missed. So again, if you've got a problem child, that may be something to look for. And check for thread slop, boogered up threads. There's tools out there that you can buy to help with those. Believe it or not, bad threads will affect your bearing adjustment. Even if you've done a bearing adjustment by the book, TMC RP 618, that's what Stemco preaches. That's what at RevHD we preach. That's what SKF, Timken Bearings. And if you do follow that, and it's a pretty arduous task to follow it by the book, you should get a perfect bearing adjustment every time. If you don't, I would argue that either your torque wrench wasn't calibrated correctly, or maybe you had thread slop or boogered up threads on the spindle, and now it's affecting the bearing adjustment beyond what you're doing with your torque wrench and counting the threads and all the things that TMC wants you to do. Clean everything. Shoot for hospital clean. Shoot for sterile. I know that's not possible to achieve in a shop environment, but make it your goal. Because with a bearing adjustment of 1 to 3 thousandths, and that's what you're trying to achieve, they'll allow up to 1 to 5 thousandths. That's within the thickness of a human hair. So one piece of metal shaving, one piece of oil dry, can get into those bearings and really wreak havoc. And so clean, use the VAR saw, use your wire brushes, get into the hub, get into the bearings, and if you are leaving the race, get in behind that race where it meets the hub bore. Take a small flathead screwdriver or that paper clip that you use to clean the plug out on the hubcap and go around that race, and you'll be amazed what you pull out of there. And then clean the spindle shoulder, and this is important two ways. It's important for seals, particularly depending on the seal you're using. My preference is a wider seal. RevHD happens to have the widest seal on the market. That means you're covering more real estate. That can become a bad thing, though, if you don't clean the spindle shoulder all the way back. Some seals are narrower than others. If you take a wheel end down and you only clean the spindle shoulder where that old seal was riding, and then you go back with a wider seal, and it doesn't have to be ours. National is a pretty wide seal. Stemco is just, kind of behind them in width. Now you're pushing that seal up on all that dirt and debris and rust and that's collected over, God knows how long, and that'll ruin the seal. It'll either tear the rubber so that it has a leak path right off the bat, or it'll cause pressure and heat is seal's worst enemy. Now let's talk about reassembling everything. What parts you're going to choose and why. Every shop has a preference, and There's usually a reason behind them, and none of those reasons are invalid. There are two-piece seals out there, and there are people who love them. There's one-piece seals, and there's metal-coated seals, and there's rubber-coated seals. They all have their place. Generally, if you're using a two-piece seal, I find that guys are using it kind of as a repair kit. They are using it for those bad spindle shoulders. They're putting a brand new wear surface on that spindle shoulder by adding that extra piece, that wear sleeve, that speedy sleeve. Now the seal is not riding on the shoulder, it's riding on that wear sleeve, and that protects the seal. Again, our seal is wider, and that's a good thing, but you do have to clean the spindle shoulder all the way back. Another thing we do, and I think I've got a slide coming up a little bit later on it, in every box we include this seal bond is what we call it. And the idea behind it is it takes the place of a two-piece seal if you have older equipment. You can use it with newer equipment too. It's pretty simple. You just put a nice bead around the OD, a nice bead around the ID, smear that around with your fingers just before you install the seal. And then it's really cool what this does. It makes the rubber swell. And we already have more rubber than any other seal, both in width and depth. Now picture a hub that's maybe worn over time, or a spindle shoulder that has really deep pit and spawn marks, scratches, scarring, or even that chisel mark that we talked about. This rubber will fill those cavities in completely so they don't become leak paths. And again, I think I have a slide on that in a little bit, and I apologize if I got a little ahead of myself there. Now, when you install the seal, we talked about having the right tool. A couple of things there. Stemco, most SKF seals, national seals, most seals on the market, they want you to use their tool. Depending on the manufacturer and the rep you have, sometimes those are easy to come by and sometimes they're not. Sometimes they're free and sometimes they're not. But it is important to have those tools. And here's something you may not know. You don't ever want to use a Stemco tool on a national seal. You don't ever want to use a national tool on a Stemco seal or an SKF seal. They actually manufacture the tools to kind of booby trap other seals. Now, one way you can kind of get around that is flipping the tool plate over to the flat side. Either way, if you're using one of the big three, as I call them, Stemco, National, SKF, you shouldn't use these as a tool. And again, I know a lot of shops do it, and some seals will handle it better than others. But all seal manufacturers, except for us, and I'll go over that in a second, will tell you not to use a hammer or a block of wood or something like that. Use their tool and the one specified for that part number. That means if you're stocking 6 different seals, you need to have 6 different tools. And if it's a service truck, that's taking up a lot of space. And of course, Murphy's Law, you get out to where you're going, and it was that 7th tool that you needed. It's important, though, to use the proper tool for that seal, because again, the seals are delicate. And if you crimp them a little bit, if you dent them a little bit, then you've done all that work in vain. The RevHD, and again, I hope you're okay with a little bit of advertising peppered throughout, is a seal that is designed with the tool on top of the seal right out of the box. And I might ask Mark Appleman to come up here and maybe pass this around. The top plate of this seal is 1/8 of an inch of solid steel. It's essentially a tool plate mounted on the seal, and here you go. And it allows us to print right on the box, install it any way you want. Use anything that's flat and clean. So again, if you are using a tool, I do want you to flip the plate over to the flat side. But now you can use a block of wood. You can use a hammer. You can use the heel of your boot. Just promise me you're going to dust it off before you do. Anything flat and clean. It's 1/8 of an inch of solid steel, so you're not going to dent it. You don't have to listen for that change of pitch. If you've got a guy in the shop that gets a little overzealous and he's ruining seals because he hits them too hard, you're okay. Even if you've got a guy in the shop who does everything perfect, when he goes to dock that hub, if he hits the spindle or he hits the shoulder, you're okay. And even if all your guys are perfect, but you got drivers who are going out there and hitting curbs and are going off-road and getting into landfills or logging, that's the part of the seal that's exposed, right? Now you've got 1/8 of an inch of solid steel protecting that seal at all times. And I'll let it kind of pass around so you can see it and feel it. It makes the seal heavier. It is a heavier seal. It's a thicker design. But I really like that you've got that part of the seal that's normally the most delicate, now giving you 1/8 of an inch of solid protection. It even helps with heat off the brakes if any of you guys are working on garbage trucks or school buses that start and stop a lot. Two-piece seals, again, A little different animal. Some guys love them, some guys hate them. Most guys, whether they love them or hate them, they're using them as a repair kit. And again, the way they're installed is you've got a second piece that's going to go on the spindle shoulder. There's usually a separate tool. Not usually, always. So now, if you're stocking 6 numbers, you need 12 tools. One to install the seal in the hub, and one to install the speedy sleeve onto the spindle shoulder. Generally, you'll tap these on. I recommend a rubber mallet hammer. At some point, you'll hear a change of pitch or a thud, and that usually means that you've bottomed out. Still a good idea to kind of take your thumb and gently go around the speedy sleeve. Make sure you've bottomed out all the way. And on these seals, and only these seals, you can use silicone or Permatex number 2 or some sort of adhesive. But I promise you guys, what's good for the goose is not good for the gander. And these seals were the first seals to come out. And so some of those older guys think, well, Stemco tells me use Permatex. Number 2 is what they recommend, but they'll tell you can use silicone and other things. They'll recommend it for the 2-piece seal. As long as it's metal on metal, you're fine. But that stuff will kill a rubber seal. And I've seen a lot of guys tell me, well, if it's good for this seal, it's got to be good for the rubber seals. And it's not. That silicone is sand. That's what's in it. And that over time will act like sandpaper and an abrasive, and it'll take the rubber right off the seal. And again, this is the slide that I was kind of jumping ahead of myself. With this stuff, you don't need a 2-piece seal. We've got tons of testimonials on our website from people who were using 2-piece seals on old equipment that had really bad spindle shoulders. And they put this stuff on, and that seal swelled, and it filled them up. And many of them have told us they did a better job than a 2-piece seal. I think that's because it's not only working on the ID, it's working on the OD also. A 2-piece seal is just going to help you with the ID. This stuff that we give you in every box is going to make the ID swell, which is great, but it's also going to make the OD swell. And guess what? That creates a push-pull kind of effect that makes the seal ultra tight and causes that rubber to fill in any imperfection, large or small. Another tip, and you heard me say it earlier, I do think a lot of premature seal failure, if it is the technician, their fault and not the hub or the worn spindle shoulders or the driver, I think a lot of times it happens at the point of docking the hub. The recommendation is to dock it gently. When it wants to stop, you stop. Don't try to force it. Get that outer bearing in there, and then let that inner nut on the double nut system or the single nut that you're using, let it do all the work for you. It'll seat that seal far more uniformly than you could ever do it by hand. And you don't risk doing what to the seal? Well, it's a lively group. Cocking the seal. Because remember, cocked seals is one of the leading causes of seal failure. And this is probably my favorite feature of our seal. It's what got me to leave Stemco and follow these guys. It's hard to convey over the phone. It's hard to convey on a brochure. But as this seal goes around, take that inner part and it's almost like an accordion. Our seal, we call it the flex design. I sometimes refer to it as wiggle room. But we're all guilty. We've all installed a seal a little crooked. Or docked the hub and that got it crooked. Or it left the shop and you've got drivers that are hitting curbs and potholes like they're aiming for them. This is the only seal that warranties off-road because it's the only seal that can do this. And that's pretty cool. The seal can ride permanently cocked. It can ride in and out with a slightly loose bearing adjustment. It can ride if it's out and not totally bottomed out. So we talked about the guy who hits seals too hard. What about the other guy in the shop who doesn't he's too gentle. He doesn't hit them hard enough and he doesn't bottom out. This is 1/8 of an inch of insurance. And 1/8 of an inch of the spindle, guys, that may not sound like a lot, but that equates, depending on the profile of your tire, that can equate to up to 1 to 2 inches of movement at the top and bottom of that tire. You ever driven behind a container chassis in which the wheel was kind of doing this? Again, going off-road, Stemco, National, SKF, any warranty package you've gotten from the OE or on the aftermarket is null and void on any equipment that goes off-road 20% of the time or more. Our seal has a no questions asked warranty even on off-road equipment that's off-road 100% of the time. Part of that has to do with that steel top plate that's going to protect it from any debris. A bigger part of it is this flex design. It's going to allow that hub to have some mobility without causing the seal to shift to the point that it's leaking. Now, if you cock it more than 1/8 of an inch, we'll start leaking. But that's when you get into that realm where, again, you want the seal to fail at some point. You want it to fail if you've got a major issue like that going on. You don't want the seal to outlive the bearings. Proper lubrication. This is another one that it's getting harder instead of easier because there's all these different lubes out there now. In the old days, you had hard pack grease, and you packed the entire hub, and you packed the bearings. But that stuff had a really thick, the viscosity was such that you could walk away, and that stuff wouldn't start water falling on the floor. In the 90s, everything shifted, and everybody went to oil or gear oil or synthetic oil, and with that, you just kind of fill the belly up until it's starting to trickle out. But in the last 5 years, most of your trailers are coming with this new stuff. Some people call it synthetic grease. Some people call it semi-fluid grease. It's the same stuff, just two different names. And with it, they want you to fill the hub up halfway, which can be harder than it sounds because it has a viscosity that's actually closer to oil than grease. And so a lot of technicians tell me they can't even get it to the halfway mark before it starts to waterfall out on them and waterfall out on the floor. If you are using the greases, either semi-fluid or hard pack, you want to pack the bearings. Always lube the spindle, and with all this, keep the same lube throughout. Don't use hard pack grease in your bearings and oil in your hub. Most guys don't do that anymore, but I still see it sometimes. And you can get away with it on certain lubes, but if that lube manufacturer changes something about the compound of that lube and how it's made, or they sell out to another company, some of those lubes can interact negatively, foam up, create heat, which will, at the very least, ruin the seal and could cause a potential wheel off. So how do you do that semi-fluid grease? Here's a nice tip. Take a piece of cardboard. If you've got a fleet that's all you've got, maybe invest in a putty knife. Buy one for each spindle that you've got and cut a half circle diameter in it that is the width of your trailer spindles. And now you just put it up there. It stops at the halfway mark, and it holds the grease until you're ready to put the outer bearing in. One of the cool things that RevHD does is we provide that for you on the back of the box. Whichever seal you buy, it's going to have these cutouts. And you pick the one that is the part number you've bought. Cut that half circle out, and the back of this box marries up to the spindle like a glove and stops at the OE spec fill level for semi-fluid grease on that hub. So your techs aren't eyeballing it or guessing. They know the OE spec. They're going to put the precise amount in every time. And then the really cool part is we made the box extra thick enough that when you get it to the full line, it's going to continue to hold the grease in place. None of it's going to come water falling out on the floor. You get your outer bearing lubed up, ready to go, and whenever you're ready, you slide the bearing in as you pull the cardboard out of the way, one fell swoop. It's simple. It's not rocket science, but it's effective. And I think it goes to show that these guys, they eat, live, and breathe wheel seals, and they thought of everything. And this can be very helpful for fleets that are getting a lot of these trailers with the semi-fluid grease. All right, proper bearing adjustment. How am I doing on time? Because this is, as I said before, to me, the most important part of the class. Running a little longer than I thought, so I'll kind of go through this a little quicker. Know that the procedures of all bearing adjustments is on a chart that you can find on our website under the training tab, and you can print that out as a PDF. It'll show you everything I'm about to show you now, and of course you can give it to your techs. They can put it on the wall or keep it in their toolbox, and they'll always know exactly what they want to do. There's basically two systems out there. Three, but two of them are very similar. You've got the adjustable hub, the manually adjusted hub. And then you've got these new, actually they're not new anymore, right? They've been around for over a decade, preset hubs. And under the preset hubs, you have two categories. You've got a true preset hub, and then you've got, and they're rare, but you can find them sometimes, these unitized hubs. A unitized hub, you can't take the bearings out. And some of them, you can't take the seal out. When you have to replace them, you buy a whole nother unitized hub, and they're not cheap. But that's, if you're going to keep that system, and of course you can always go to change it to a manually adjusted hub, but if you're sticking with that system, you'll buy a whole new hub with the bearings, the races, the seal, as a complete package, as a cartridge, if you will. Let's take a look at each, and let's start with the preset hubs. The good news about a preset hub is the bearing adjustment is simple. The bad news is it's simple only if you know the torque for that spacer in that hub from that manufacturer. And everybody's got a preset hub now, and even though Conmet kind of has the lion's share, Conmet has 3 different spacers with 3 different torques. And again, you may have a Freightliner come in, a 2010, you do the steer, and you call everybody and you Google and you find out that spacer requires 350 foot-pounds. Well, great. And the good news is you torque it to 350 and you're done. There's no counting of the threads, there's no backing off, there's no turning the hub and doing all the things that you have to do with a manually adjusted hub. The bad news is if the 2011 Freightliner comes in, I happen to know for a fact that the original spacer on that calls for 650 foot-pounds. So that technician who did all that work and he's got it memorized and he's grateful that he doesn't have to do it again is now going to probably go ahead and put 350 on a spacer that requires 650, or vice versa. And he's going to have major issues. At the very least, the seal is going to leak quickly, and at the worst, he's going to have a wheel off. So you've got to know the torque for that spacer, and unfortunately, they don't print it on the spacer. I don't understand why, and they don't make it easy to find. And so I feel for you on that one. You can remove the spacer and make it a manually adjusted hub. Just be careful if you're doing that on a new piece of equipment. You may be voiding the warranty if you do. But technically, you can do that. If you do that, they do recommend you replace the bearings also. If you're keeping the spacer in, know the torque, and then it's pretty cool. It's simple. It's one torque, no back off, and you're done. But let's say you want to convert it to a manually adjusted hub, or it's already a manually adjusted hub. Now the bearing adjustment's a little tougher. And some of those still have the double nuts on them, although a lot of people have started gravitating to the single nuts. There's different ones out there. They've got two different bearing adjustment procedures for the most part. There is a little bit of, I don't want to say an argument, but there are companies out there that push for preload, and there's some that push for having some sort of in-play. We're an in-play company, but there are some out there that ask for preload. Decide for yourself what you wish to have on your wheel ends, and then follow the specifications for that nut on that spindle. If it is the double nut system or the single nut system, the good news is, again, that chart is on our website. And you'll see how it gets into things like counting the threads per inch. And I know most techs don't do this. But again, if some of you were in that last class, I almost wish that class was mandatory before this one. They put the fear of God into some of those techs and drivers about liability. If you have a wheel off and a lawyer is called out and that lawyer is worth his salt, he's going to check the in-play on some of your other wheel ends. He's going to check that torque wrench. He's going to see if you have a dial indicator. And he's going to ask you, did you count the threads per inch? Because every spindle is a little different. Every spindle should get a different bearing adjustment procedure. These charts will walk you through it, but you do have to count threads. You have to measure. You have to know, hey, is this a steer or a drive? Is it a Rockwell? Is it a Meritor? Propar, Fruhoff? But if you have that information and you follow this chart, minus human error, somebody torquing a torque wrench to 300 instead of 200 because their eyes are like mine, or a torque wrench that's not calibrated correctly, or pinch threads like we talked about earlier, then you should have a perfect bearing adjustment every time. And the basic premise is this. You'll start off with 200 foot-pounds. Now, the first torque has little to nothing to do with the bearing adjustment. And this goes for the single nut or the double nut. 200 foot-pounds is just to seat that hub, get everything where it's supposed to be. And it is recommended that when you hear the click, you spin the hub a few times, click it again. Make sure you've got a true 200 foot-pounds. And use a calibrated torque wrench. Don't be one of these guys who tells me your elbow pops at 200 foot-pounds. After that, back it off till it's loose. Again, the first torque has little to nothing to do with the bearing adjustment. Some guys will say, I've heard back off a half, and that's usually loose. So you're starting over, and go back on a double nut system with 50 foot-pounds. A single nut's going to be a little different here, and we'll cover that next. But on a double nut system, you'll go back with 50 foot-pounds. And again, they want you to spin it, click it, 2 or 3 times to make sure you've got a true 50 foot-pounds. And then, counting the threads per inch, do your back off. Sometimes it'll be a quarter turn. Sometimes it'll be a half a turn. Sometimes it'll be a third of a turn. I talk to a lot of guys who say, I always do a quarter. Okay, you're right. A little better than half of the time. Some guys tell me they always do a flat, which is usually around a sixth of a turn. Okay, you're right on steers that have 12 threads per inch, but you're wrong on everything else. And again, you want to have 1 to 3 thousandths in play, because if you ever get called on the carpet and the lawyer comes out and they take these measurements, this is where the liability kicks in. Put the locking nut on, put the star nut on, and then the jam nut. Again, a lot of guys tell me they just torque it down till their elbow clicks. That's not what you should do. You should have a torque assigned to it, and guess what? Here again, different torques for different applications, and the chart will walk you through it. Even after doing all that, I still highly recommend, preach from the mountaintop, that you should use a dial indicator. Again, you could have errors in judgment, you could have thread slop, you could have worn equipment. Make sure you have 1 to 5 thousandths in play at least. Recommended is the 1 to 3 thousandths in play. The single nuts work a little differently, and some of them are nice enough to put the bearing adjustment procedure on the nut for you. This one is ours, and it's made in cooperation with Tempur Corp. This nut can be used with the Dr. Preload tool, which is a great tool, and it can be used with a socket. On our version of it that we've made, again, in cooperation with Tempur Corp, it has these markings on it that you can possibly see from the screen there. That's your back off, and that's put on here so you don't have to count the threads. We've done that for you. You don't have to do the math. We've done that for you. What I tell guys to do if they're using our nut, 211. Easy to memorize, kind of sounds like 911. What it stands for is 200 foot-pounds first. Now again, this is a conventional hub. There's no spacer. If you're using this on a spacer, it's going to be 1 torque, no back off. Again, you got to know what the torque is for that spacer though. If there's no spacer, then you're going to do 211. 200 foot-pounds first. Spin it, click it, and back it off till it's loose. Go back now with 100 foot-pounds as opposed to 50 like we did on the double nut. And then back off, we call them hash marks. Back off 1 hash mark. On the nut pictured there, there's 4 hash marks. Pick any one you want, back off to the next one, you've backed off a quarter turn. But some of the nuts that we make for different applications will have 6 hash marks. Some will have 2, some will have 3. We've done the math and we've counted the threads ahead of time and pre-stamped the nut so that if it's 6, you still just back off 1, but it's going to be a smaller back off. If there's 2, that's going to be a whole half a turn, which is a lot, but it's guaranteed to be the right amount for that spindle, its thread count on that application of that vehicle. And then put the dial indicator on it, and we guarantee if you've done 211, and again, the torque wrench is calibrated and your eyes didn't do like mine do sometimes and have the torque wrench set incorrectly, you should have 1 to 3 thousandths in play every time. So again, 200 foot-pounds, back her off, go back with 100 foot-pounds, and then back off 1 hash mark. That prevents you from having to use the chart, count the threads, and do all the arduous things there. Make sure the clip is installed correctly. Tempur Corp and our nut made in cooperation with Tempur Corp are the only clips that have a safety mechanism there. We've got these easy view tabs, little notches that are placed at each of the locking points. All you got to do is tell your technician you want all 3 of those to disappear. If you can see one, that clip is not installed correctly. The other nuts don't offer that. It's just one more level of safety, one more checking mechanism, because the Achilles heel of these nuts is that clip. If it's not installed correctly, you can have big issues. Tell them to look for those easy view notches, and they'll know they're installed correctly every time. Again, always use a dial indicator. Now install your hubcap. Fill it up between add and full if it's using oil. Coat the inner walls if it's using semi-fluid grease or hard pack grease. And at this point, we've eliminated the top 5 leading causes of seal failure. You're not going to have any bad installation because you're going to get the right tool for that seal and you're going to use it properly. Or you can go to ours. And again, with ours, you don't need a tool and you don't have to handle it so gingerly. Incorrect bearing adjustments, you're going to get that chart either off our website or the TMC website. It doesn't matter to me, but you'll follow that chart to the letter and you'll have a perfect bearing adjustment. Or you can get our nut called the RevLock nut and just simply do 211. Bad shoulders, bad hub bores, you're going to take that emery cloth. Again, that's going to help most of them. If they're really bad, you're going to use a 2-piece seal. Or, again, if you use ours, we've got the seal bond that actually doesn't, it's not an adhesive, and it doesn't really do anything in and of itself, but make the rubber swell so that the rubber fills in those cavities. Contamination kind of falls on your shoulders, but I will tell you that our new hubcap that we're coming out will have a contamination-proof plug, and that's kind of nice for both the cleanliness aspect and the fact that those plugs can get clogged up generally on a standard hubcap. I'm done. And again, when you leave here at any time at your convenience, now or 3 weeks from now or 3 months from now, you can go on our website, take a short quiz, and if you make an 85 or better, you'll get a certificate that goes along with this class. And with that certificate, if you do use our seal, our warranties, which is 3 years on the RevMax seal, and that includes off-road, and it's no questions asked, with that certificate, it now also includes your brakes. Any brake kit you want. New steel, disc brakes, doesn't matter. And it's always no questions asked. You can literally tell us, hey, my guy put the wrong seal in backwards. In fact, we had that happen this week. And we warrantied the seal. And we paid for their brakes. I appreciate you guys having me. I think I went a little over time, but if we're the last class, then maybe if you have questions, we can take a few. Yeah. Any questions? Well, then I will. Our products are priced below, slightly below the other guys. We do 2 things with pricing. We, as I just mentioned, priced ourselves a little bit below. So if you want to try us out, you're not going to pay extra for us. Another thing we did is whether it's the seal or it's the nut, they're all the same price. You know, the other guys, the steer is a little more than the trailer, and the drive is, man, that's kind of where they get you in the shorts. We priced ourselves a little bit below everybody's trailer seal, which is generally their lowest price product, and then kept that price for the steer and the drive, so we can save you a lot of money on your tractors. Check with your distributor to get true pricing, and if you don't know who your distributors are around you, on our website is a Where to Buy tab. Click it, put in your zip code, and it'll show you all the distributors and within a 100-mile range of where you are that carry and stock RevHD. I think you'll be happy with the price. I know you'll be happy with the quality. Anything else? Well, all right. I appreciate Mid-America for having me. I appreciate you guys for attending. And if you ever have any questions after today, feel free to get on the contact page of our website. Ask anything you want. We're always here to help. Hope you guys enjoy the rest of the show. I hope you have a good evening.